Okay, hello students. This is I'm working through. Before I begin solving the practice problem, so what is the lesson about? Is let's check that out. Uh, there it is. So the name of the lesson. This is lesson number 3, and it says introducing polynomials. So what are polynomials? What are the things that we need to know? The goal is to understand. Let's see what polynomials can look like. Okay, and then also I can identify important characteristics of a polynomial graph and expression. So what basically this is, as we are working on the problems, I'm going to walk through this, what the characteristics of polynomial graphs and expressions. So I begin with the very first problem, and I want you to look at this graph. So you see something here, and yet at this moment you may not know uh, what this graph represents. Look at this. So it starts from up here and then it goes downwards. Okay. So what are the characteristics of a polynomial? So in this question, select all the points where there is a relative minimum values occur. Now, what is the relative minimum? Question is, what is relative minimum? If you see this graph starts from top, okay, then it goes down. Then you'll see there is a which is the x-intercept. So if I ask you, so these are the characteristic of a polynomial function. Characteristic. So I want you to write this characteristics. I think I did not write it correct. Characteristics. Okay. I hope my spelling is correct. So one thing you have to know is what is the mm, how the graph looks like. First is the graph is up down. So that's one thing. First step. The second thing you see there's a x-intercepts. So this x-intercepts, they are also called the zeros of the graph. Zeros. What it means, or they are also called a solution, or where the graph crosses crosses the x-axis. And when if you look at it, so at A, and the point is at A is like this one. It looks like it is minus 9 comma 0. So the x-intercept is minus 9. This is just less than, if this is negative 5 here, it will be between negative 5 and negative 6, close to maybe negative minus 5.9. And then there's another one right here between 6, 8, and 7 will be this one, will be 7.5. So these are called x-intercept or zeros. So the first thing is, what are the characteristics of this graph? If the x-intercepts are, so maybe x is, the one that I took is minus 9. That's one of the x-intercepts. Also, this is around minus 5.9. And the third one is here, which is x is 7.5. Okay, so this is one of the characteristics. One more thing you can clearly see is what is the y-intercept? Where does the graph crosses the y-axis? If you see here, and then I will come to the actual question. I want you to copy down the understanding of what is x-intercept. So we got that part, and what is the y-intercept in this case, or it's also called the vertical intercept. These also are called the horizontal. So another word is used is horizontal intercepts. It means where the graph crosses the x-axis, this x-axis. And this point, which is right, is that this is maybe it is around. Maybe this is 4. As I'm assuming it is 4, so that's a y-intercept, which is 0 and 4, and that is called vertical intercept. Okay, so I hope this is taken care. And then comes question: what is the relative minimum? Now, relative minimum basically means you'll see there are. If you see the graph decreases, increases, decreases. So good thing is you should know that part also, what is increasing, decreasing, and you can clearly see it. This graph decreases until this point. Can you see that? And then it increases. So that's kind of in the neighborhood around this point, somewhere here. This point, whatever that point is at B. So the B is a point, B is a point. Exactly what point? We don't know. We'll have to check it out maybe. Let me check on approximately something here. This is the x. If this is -7, this is maybe minus negative 7.6 or 7. So it's like minus 7 point. This is just approximated. And the y, so I have to go all the way this way. Maybe it goes somewhere here. And that's -4. So it's -4. So that's called relative minimum. So the question was asked, what is the relative minimum here? So the relative minimum is -4, but where does it occur? Where does this occur? It occurs at x equals -7 points. Now also there's another relative maximum. Look at that is also here that there is a valley. So you are looking up for relative maximum minimum where there is a valley. So there is a valley right here and there is a valley right here. So that's the point. So this is the point. This point is at 12, but the minimum here could be maybe minus 2.5 maybe. So that's another, that's E. So E is the point which is at 2, it is minus 2.5. So this is the another relative minimum. So this is relative minimum. So relative minimum does happen whenever there is a change in the from change in the graph when it is from. So how do we know? So one thing is there should be a valley. That's where the so there is a and then on the left side it decreases, goes down, and then there is the lowest here, and then it goes increases. See, and that's why this is called relative minimum. And then also here, this goes decreases. So this part decreases, and then it increases. So there's a value here, and that's another minimum. This is relative minimum. So the question was asked, what is the relative minimum? And the answer is, it does happen at B, and it also happens at E. So these are the relative. What about relative maximum? Let's write that relative maximum in this example. So the relative maximum is the one where there is a peak. Now just look at this peak here. There is a peak here. There is another peak right here. It means on the left side, it increases. See, the height goes on increasing, and there's at one point it's like maximum. There is a maximum, and we don't know exactly at what point. Maybe at this one after -2, I'll put minus 2.5 maybe, and then this side will be maybe 6. It is so because 6, 7, 8, 9, and 10. So this will be the point. Will be maybe minus 2.5 and 6. So 6 is the. So let me clean this up and just write it nicely. So that is, so this point D is a point where there is a relative maximum, and that is almost like maybe 6. I don't know whether it is 6, but I put 6. And it where does it occur? It occurs at minus 2.2. So that's one of the relative maximum. And you can also see there's a F also is relative maximum, and that is exactly like a 5, maybe 5. And that happens exactly at 6. So hope that is understood what is the relative maximum and what is the relative minimum. Then what is the meaning of the decreasing the graph? This side the graph decreases. Then there is a relative minimum. Then there is increases. There is a x-intercept here. Then graph increases again and then decreases. There is a y-intercept here. Then again there is a value. The minimum it goes, and then again it increases, and then all the way down it goes down. So what basically that means going down is it's like negative infinity. So it becomes a very large negative, negative, large negative output, or also the y coordinates. So the y coordinates. So as this graph goes down like this, as this graph goes, so the y coordinate goes on in becoming very very large negative values. And on the left side, this side, they become very large positive. So understanding of the range part. So what is the range of the graph? Range of the polynomial function is from it goes up is is down, it goes until minus infinity here. So this is negative infinity. And it covers the whole y-axis in this part. So it covers the whole y-axis like this. And then this side, it covers everything of the y-axis. This whole y-axis is taken care. And that's why we call it as and the domain also is on the x-axis. You said the domain and the what is domain means what should be the value of x. So let me clean this. This become too much. Okay, so that's what I wanted to show. And you see one more thing I also want to show you. The graph takes 4 turns. Can you see this is one of the turn it takes from decreasing to increasing, then increasing to decreasing in the second turn, then decreasing to increase third turn, then again increasing to decreasing. So it is 1, 1, 2, 3, and 4. So whenever you have 4 terms like this, so then what's the polynomial? The expression could be so the degree is always one more than the number of terms. 1, 2, 3, 4. So this has to be 5, and then maybe something here, and then plus something x raised to 4, and that's how we are in later classes we are going to check some number times x raised to 3, some number times x square, some number times x, and plus a constant. See, so this is how we are going to write the polynomial function where this could be a, b, c, d, e, f. All these are, so this a, b, c, d, and e are called coefficients of the new word. So I wanted to copy down this in the paper that I showed, coefficients of x. And here the degree, so what is the meaning of degree is basically the highest exponent. So in this example, the one that I showed here is 5. So we say the degree is 5 here. And the last term that is called remaining is always called constant. So this is how we get the understanding of all the characteristic of a polynomial. So you not, and then you see this thing. I can just blindly write Rx as a polynomial, and I'll just put like 2x raised to 5 minus 5x raised to 4 plus 7x cubed minus 3x squared plus 2x. See, this is the poly. Poly means many monomials are combined here. Okay, so this is one monomials. All these are monomials. And why are they monomials? Because you're multiplying a number. So you're multiplying a number to the variable with the exponent which are either 0, 1, 2, and 3. So you cannot have negative there. Okay, this is the second question. And the second question is saying add one term to the polynomial expression. So you're given something here. And you say you want to add another expression means you're saying add monomial. That's what it's trying to say. To make it into a 22nd degree polynomial. Now, what is that 22nd degree polynomial means? This is stays the same. See, this whole thing stays the same. All you do is you just add up another one plus here and put an x. And because degree is always because it says 22nd degree means the highest power is 22. And here you can put anything here, could be 1 or 2 or 3 or minus 1 or minus 2 or anything here. Because that has to be a real number. This has to be a real number but cannot be 0. That means if I want to write something here, it cannot be 0. So if I write here, I cannot put a 0. If I put a 0, because anything times 0, this whole thing will collapse, will go away, and you are back to the one that you have in the beginning. We had 19. The degree here, this polynomial had a degree of the highest was 19 there exponent, so that's the degree 19. So this has to be anything other than 0. So non-zero real number. The coefficient. So this also is called a leading. Now in this example, one more thing you have to notice the degree and leading coefficient. Two more things to be understood is this is a polynomial with the degree is 19. That's the greatest or the highest exponent 19 because the others are 15, 4, 2. And this 14, the coefficient, that's the coefficient which is the term that has a leading, so the term that has shows the degree. So this is the term that has the exponent, the highest exponent. So that 14 is called 14x raised to 19 has a name and it's called a leading term. Now why it is called a leading term? Because it has the highest exponent, which is 19 here. So take note of that. So the whole thing is called leading term. This is called the leading coefficient. 14 is called the leading coefficient. The whole thing is leading term, and the 19 is the degree. So what are the things you are learning? This is degree of the polynomial. This whole thing is leading term, and this 14 is leading coefficient. I hope that takes care. Now, when you add one more here, now everything changes. See, I could have just made 5, this whole thing. So what is the leading term here is? So the leading term is 5 raised to x raised to 22, and 5 is leading coefficient, and the degree of the polynomial. This whole thing is polynomial is 22. I hope that takes care of that. Now this question will help us. Question number 3. Identify the degree. Okay. Then the second question. What is the leading coefficient and the constant term? Now if I choose the first one, say x cubed minus 8x squared minus. So you look up for the degree. You have to see the biggest exponent. This is 3. So that's the big one. This is the big. That's the degree. The others are 2. So this is 2. This is 1 here. 3 is the highest exponent, and that's why it is the highest exponent. And then what is the leading coefficient? Is the number that multiplies the variable. This is the leading term. This whole thing is the leading term. But you don't see no number in the beginning. That means the number is 1. So that means the leading coefficient for the first one will be the 1. So this is the leading coefficient. And the constant term is the number by itself. That's the constant. And later on, you will see that it's a nice thing. If you want to see the graph of this cubic polynomial, there is a degree 3. Whenever there's a degree 3, it is also called cubic polynomial. And the cubic polynomial usually are always like down up, something like this. And if in the beginning, if it is positive like this, there's a positive one. And the main thing is this plus 8 is this is the when you put x equals 0, if I put x is 0, this x is 0, this everything goes away, and you're left with 8. So 1, 2, 3, 4, 5, 6, 7, 8. The graph may grows to 8. That's what it is. And maybe something like this. So that's the idea where the cubic polynomial shows down up from minus infinity goes to plus infinity. And at the same time, the graph crosses the 0, comma 8 there. That's the vertical intercept. And that's one thing 100% I know, but I don't know what point, what is this one we don't know. And for that we have to do later classes. We will see how to do that. Okay, the second part, this question you can see here, if you look at it, the 4 is that the degree because that 4 is the greatest because this is small, this is 1, the 3, and this is 1, and this is the leading coefficient, and the number by itself is the constant. And the third one I want you to try. Let me go to this question number 4 is kind of a review from the lesson number 1 and 2. You want to make an open top box by cutting corners of the square piece of cardboard, folding up. The cardboard is 9 by 9, so there is a cardboard which is 9 inches by 9 inches, and you're going to cut off square of side length x, so when you do this, this will be 9 minus 2x. See? We're going to cut off squares at each corner of side length x. So there's a length and width. So this also is 9 minus 2x, and the other one both 9 minus 2x, and you kind of get that 9 minus 2x here, and there you go, and you can have a box there. Mm, so you get a box like this. There you go. So this is the height x. So we have a volume. So the question is, what is the volume, length, width, and the height, right? So the length and the width are the same, 9 minus 2x. So I can write 9 minus 2x, and because there are two times you're multiplying, so I can put a square there. And the height is x, and you're done. The next question you put, what is the volume when x is 1? You just plug in 1 here. So you multiply by 1. Square and multiply by 1. So this will be 2 and take away from 9. 7 times 7 is 49. So you get 49 cubic inches because it is given in inches, right? And what is the reasonable? And this is a confusing question. Now, when you have this total is 9, and if I cut off here, that's what I mean. Can we have a box? So you have to cut something, so x has to be greater than 0. And at the same time, if I cut off exactly 4.5 on both sides, 4.5 and 4.5, and you will see this side also 4.5, this side also 4.3, there will be nothing left. You're going to cut off 4.5 this everywhere, and there will be only one dot left. So everything is gone, see? So there's no box. So whatever the square that you cut off, the side length has to be less than 4.5. So the reasonable domain will be is 0 less than x less than 4.5. So where did you get this 4.5? Because you're just dividing by 9 by 2, which is 4.5. Okay. Yeah, question number 5 is just consider the polynomial function px. Now there is an expression here, and you know this the degree is here 3. And because this degree is 3, we call this as cubic polynomial. Okay, that's the names are given. Or if it is degree is 4, you will be calling it quartic. And if the degree is 5, you will be calling it quintic. Now in this degree, so this one there is a positive plus 3. So if this is x-axis and y-axis, the graph will be something like this. We don't know where it goes like this. Just a kind of prediction, but that's not a question here. The question is, what is the value of when x is minus 3? That means if we have like this 1, 2, 3, minus 3, what is the output if the input is the x is minus 3? All you do is you plug in here in place of x, you put p of minus 3. This is what you do. So it is 7 of minus 3 cube minus 2 into minus 3 square plus 3 into minus 3 plus 10. And you kind of work it out. This will be minus 27. So 27 and 749 for 14 a1. So this was minus 189. This will be 9. 9 times 18. This will be minus 9 and plus 10. You work this out and you get the answer. That's all it is. So more of a negative answer. So somewhere here, we're going here, goes down. So maybe somewhere here, you can figure that out yourself. Oh, so the answer I on purpose given, which is minus 206. Check it out. So if this is a number line, maybe this is minus 100, maybe this is minus 200, and somewhere here, maybe graph is going up, something like this. Okay. I'm combining the lesson number 4 practice problem also because almost the same thing. Lesson number 4 is about combining polynomials. What it means, you're adding or subtracting two polynomials. So you have a separate and go straight away to the problem on this. So this first problem, this is practice problem lesson number 4. Okay. And the question is, here are two expressions. So they gave you, see, there's very tricky question. Here there are two expressions whose product is a new expression. So something here. Now the question is, here are the two expressions whose product is something given. One student says that in this box, can you put anything? That's the question. Any real number can go either of the boxes, and A will be a polynomial. The final outcome is going to be a polynomial. No, I'll just give an example. Let's see, 5 raised to x raised to 4. And this box can be anything because it doesn't matter. Remember, in order to get a polynomial, the final result has to be something, whatever you have, maybe here something like this. So all this thing they have to be whole numbers. I'll just put them whole numbers. So what are whole numbers? So whole numbers basically means 0, 1, 2 like that. You can't have a negative and you can't have fraction. So when you look at this, if you see there, the first one, so I mean, can I make it bigger? Let me see if I can make it bigger. I'm gonna go quickly on this. Let's see if I had to pick. I'm just writing. Let's see if can I put a -5 here? If we put a -5, and if I multiply this by using FOIL method, okay, if I use the FOIL method or maybe box method. Now what I mean is like you make a box like this, okay, and you just put this, and this could be anything. This one thing is good is this coefficient could be any number. So this will be maybe 4. So the first one will be 5x raised to 4, and this will go here 4x raised to 3, and this one I'm gonna put here. So sorry, you put 4x raised to 3, and the last one is minus. But when you multiply, where it is, this 4x raised to minus. I made a mistake here. So this is -5, right? When you multiply these two things, watch this, they will end up getting 20 and x raised to this 4 and -5 will give you -1. So you're not going to get a polynomial with, you can't have a negative. So that won't help. So it has to be something where it has to be whole number. So the only option for here is this could be anything, it doesn't matter. But this has to be, if this is 4, you can have a -4 because that may become 0. But then that will affect here when you multiply here. This will give you -1. So this 3 and 4 will be -1. So it's better we change this to -3. See, the beautiful thing is this will help because when you multiply this one, you get 20x raised to 4 times -3, which is 20x raised x. And if you multiply this, so that will give you 4x raised to 3 times 4x raised to -3, which is 16x raised to 3 plus -3, and this will be 0. So 16x raised to 0 is 16 times 1, which is 16. So there's no issue out of it. So that's why I'm saying is this has to be -3. So take note of that. Problem number 3 says the lane divides the polynomial. So you have something like this, 2x raised to square, and it is divided by 4. So you divide by 4, doesn't matter. See, if you divide, this will be 0. Because it's going to be half, right? So 0.5x square. This 4 goes and you get x. And this will be 0.25. So that's another polynomial. This is a beautiful expression called polynomial because as long as this is whole numbers, see, these are 2, 1, This is a number, so this is a polynomial. So no issue. If you divide by a constant, whatever the polynomial, that will remain a polynomial. The original polynomial will stay a polynomial. So dividing by number doesn't matter, but dividing by x maybe that can affect. So you have to be very careful. If this is the same problem, if we have to divide by x raised to x, let's imagine you have to divide by x, all of them, 2x squared. So now remember, if you divide by x, you won't get a polynomial. And the question is why? Why you don't get a polynomial? Because the first one is okay. This is 1, right? So one of the x will go, so 2x will remain. This x will go and you get -4. But this part is going to create a problem because you're going to get that's like 1 and that's like x raised to -1. From algebra 1, you say this is anything 1 over a is basically a raised to -1. You can't have a negative. This is not a whole number. So this is not a polynomial. This question is just asking you what is the result of when two integers are multiplied. Let's say -3 times 5, you get another integer, see? Or both are integers, 9, that will be plus 27. So multiplying two integers always give you another integer. That's all the question is. So this is the last question. I think it's question number 4. Claire wants to make an open top box by, oh, this one is 30 inches and maybe 25 or something like this. This is 30, this is 25. And you want to cut off, again the same thing, how much you want to cut off all inches. So that's like x. So this is going to be 30 minus 2x, and this is going to be 25 minus 2x. So the volume here, Vx, becomes equals the length, so whatever the length here is, and then you multiply the width, and then the height, this part. So that's the volume. What is a reasonable domain? Always look up for the smaller one among this 30 and 25. 25 is the smaller one. So all you do, take half of this. That means 25 divided by 2 is going to be 12.5. So your domain will be reasonable, will be x has to be less than 12.5. That's all it is. And I hope this takes care of everything. Lesson number 3 and 4. Make sure you write all the steps and whatever I'm trying to explain, like, really trying to get you guys get the concept right, understanding what is the meaning of polynomials. So these are the things you have to know. What is the meaning of polynomial? What is the degree? What is the leading term? What is the leading coefficient? Then what is the relative maximum? What is the relative minimum? These are the things, increasing, decreasing, all these constants. And right now you may not know. Also, I think I forgot that what is the horizontal intercepts, what are vertical intercepts, what are zeros, what are solutions, what are um, x-intercepts. They mean the same thing. So I hope this is taken care, and see you guys. Make sure you do all this, write down and turn in.